Some of the values of x for which this is true. It's actually a hidden quadratic in terms of cosh squared x. So I'm going to let u equal cosh squared x. Then I'll get 64u squared minus 64u minus 9 equals 0. All right, and there's two approaches here. We could just try and factorize it by hand, which is a little bit awkward because of the size of some of the numbers. Or you can use your calculator and kind of work back. I would strongly advise, even though it says relying entirely on calculator technology, but that just means like the whole thing if you just stick it in your calculator. We can use our calculator to use a quadratic formula here, for example, but I'd strongly advise still to write it in factorized form. So we're going to get a u and a u and some coefficient, which we'll deal with. And then we're either going to have a minus 3 and a plus 3, or if that fails, we're going to have a 9 and a 1. But to get the minus 64, this is going to have to be minus 9, surely. I mean, I guess I could be wrong there, so I won't put it in quite yet. Now, if you try 3 and minus 3, this is what I did, then you quickly find it fails. If you try 64 and 1, no, that's way too big. 32 and 2 isn't going to work. We get like 96. Okay, it'd be the other way around. It'd be like this one would be larger. If you then go with, say, 16, you get minus 48. It's not big enough. So this one has failed. And then you can do a similar sort of approach here and eventually see that 8 and 8 works with this being minus and this plus. You get minus 72u and plus 8u. So u is going to be 9 over 8 or minus 1 over 8. Now, I'll just show you how you do it on your calculator. You may already know this. Apologies if you do. We can go to equation function, we go to polynomial, type it all in. And you just get your root straight away, 9 over 8 and minus 1 over 8. But the thing I'm trying to say with this is that you can then use that to help you factorize, because it would be u minus 9 over 8 and u plus 1 over 8. But because we know the leading coefficient is 64, I need to times through by 64. So I can times the left-hand bracket by 8 and get this, and the right-hand bracket by 8, and we get the same thing. So you can just help yourself factorizing when you've got your calculator in that way. Right, now remember, u is cosh squared x. Okay, this frustrates me a little bit in this question because it says it determines the values of x. It doesn't say they have to be real. It's only later on that it says it has to be in the form q ln 2, where q is rational. That's really implying that it has to be real. I mean, when A-level maths, you just do it straight away. You just reject this one. But I just feel when we're in further maths, we need to, could potentially consider complex solutions to this question as well. And there would be, I believe there would be, yeah, another 2 coming from there. But in this case, because of the way the answers is that are asking, we are going to reject that, and that is expected. Then cosh x, we can just take the square root, and we're going to get 3 over 2 root 2, but don't forget your plus and minus. Now, this plus and minus in this situation is actually a very important point, because let's say we've got x squared equals 9, then x would be plus or minus 3. We would find both answers to this equation. But if you're ever asked for the square root of 9, then you just get positive 3. So that's the difference between solving an equation and using an inverse function. Square root of 9 is defined, it has to be a one-to-one function, and it just gives us one answer. And if you just use inverse cosh on this, you will get into some difficulty because there's another like solution to this equation aside from just putting it into the inverse function. Just like up here, you can't just find the square root of 9. You have to also find minus the square root of 9. And therefore, if I'm solving if I get rid of if I want to solve cosh x, wait, not cosh x, cosh, yeah, if I want to solve cosh y equals x, then that means, that's it, I'm doing this right now, y would actually equal this, but there's also a plus and a minus here, and I will show you where that comes from at the end. But you must include that in this. You must say, you can't just fall into the trap of putting it into the inverse function, because we're actually not doing that. We're solving an equation. Another comparison is if you ever find inverse sine of something, you only get one answer. But if you try and solve sine x equals a half, you actually get like an infinite number of solutions. So there's a difference again between putting it into the inverse and solving an equation. And when we're solving this equation, we need the plus and the minus. Don't forget what cosh looks like. It is an even function that looks a bit like this. Okay, so hopefully I've convinced you there are going to be two values for that's just for the 3 over 2 root 2. Like what about the minus 3 over 2 root 2? We'll get into that in a second. I will show you at the end where this comes from by deriving it from first principles. I think a lot of people in the exam forgot about the minus, so just be on the lookout. Right, so in our case, we are going to get that x, oh, sorry, first of all, I'm going to go with cosh x equals 3 over 2 root 2, the positive one. Then x is going to be ln 3 over 2 root 2 plus the square root of 9 over 8 minus 1. But don't forget there's a plus and minus there. Sorry, nearly forgot that. And then I'll get ln 3 over 2 root 2 plus and minus. This is going to be the square root of 1 over 8. I'm going to get 1 over 2 root 2. So then I'm going to get ln 4 over 2 root 2 or ln 2 over 2 root 2. And I put the minus in. And this gives me ln root 2 or ln 1 over root 2, which is actually the same, because how have they asked us to leave it? Q ln 2. Okay, so this one here is going to be a half ln 2, and this one here is going to be minus a half ln 2, because it's root 2 to the minus 1. Or you could imagine just subtracting it, I guess. Yeah, it's going to be ln 1 minus ln root 2. That's another way to think about it, but we will get that minus a half ln 2. Okay, so I'm just going to put boxes around these. If I now go with cosh x equaling minus 3 over 2 root 2, then we're going to get a similar sort of thing going on. X is going to be ln minus 3 over 2 root 2. Then it's going to be again plus or minus 1 over 2 root 2. But now it's going to be negative here. There's going to be less than 0, so no real solutions. So there we have it. These two solutions to the question, but you must include both. And let me show you where this comes from by essentially deriving the inverse function. Let's say that y is equal to cosh x. Now we can write that as e to the x plus e to the minus x over 2. To get the inverse function, I'm going to have to make x the subject. So we'll get e to the x plus e to the minus x equals 2y. So if I then minus that 2y, I'll get 0. This, believe it or not, is a hidden quadratic in e to the x. I'm going to create it by timesing through by e to the x. We'll get e to the x squared minus 2y e to the x plus 1 equals 0. A little bit clearer now. I'm going to complete the square. X squared, sorry, not x squared, e to the x minus y squared. That'll get me my e to the x squared. It'll get me minus y e to the x and another one. So I just need to then minus y squared, as you normally do when you're completing the square. You could also use the quadratic formula at this point. Plus 1 equals 0. E to the x minus y is going to then equal, well, I'm going to get y squared minus 1, but then I'm going to be taking the square root and check it out, plus or minus. So e to the x is then y plus or minus the square root of y squared minus 1. And finally, x is equal to ln y plus or minus. So that is what I brought in the question. I took the inverse function from the formula book and I included the minus as well, because when you create the inverse function, we cannot have two outputs. That's why we take the principal value and we say we're only going to consider the positive. That's our definition for arc cos. But when we're solving an equation, we need to include the negative as well. Something key to take out of this question, if it did trip you up, it trips many people up in the exam, because otherwise this is actually not too bad a question, but I think that final mark is very easy to lose. Well done.